Good evening, everyone. Welcome to the 201st Saturday Talk. It is a privilege to introduce Dr. Arunkumar M. Sampath sir, a distinguished technology leader with 28 years of experience across the automotive, aerospace, and defense sectors. His expertise spans sustainable mobility, 5G networks, AI and edge computing, hybrid and electronic vehicles, hydrogen and fuel cell technologies, autonomous and connected systems, and advanced automotive electronics. Dr. Sampath holds a PhD from the University of Maryland, an MBA from Lawrence Technological University, and a BTech from IIT Madras, reflecting both depth and breadth across engineering, research, and management. He currently serves as the principal consultant and global head for software-defined vehicles and eVTOL aircraft urban mobility at Tata Consultancy Services. In his role, Dr. Kumar works directly with industry leaders and CXOs to set strategic directions for next-generation mobility and computing technologies. Across his career, Sir has held senior positions at Mahindra Electric, Automobile Pininfarina in Munich, Ashok Leyland, and Daimler Chrysler's Hybrid Development Center in Michigan.
Good evening, everyone. Thank you, JanyuTech, again for giving me the opportunity. I think this is my third or fourth lecture with JanyuTech over the last couple of years. So, you may be aware of geopolitics that has been happening, especially with Trump at the throne, and you are very much aware of the challenges that are being envisaged by different economies in the world, and in fact, even the allies over the last, say, one and a half years, including the recent challenges with respect to Nexperia chips, where these chips are being withheld, and that impacts directly the automotive production in Europe, for Germany, and different parts of the world. And you are very much aware of trade being used as a weapon. You are very much aware of tariffs used as a weapon. You are very much aware of, for example, rare earth minerals being used as a weapon, where our neighboring country literally controls 92% of global processing, whereas about 60% of global mining. So lots of people around the world somehow have been in slumber, but they woke up, but they are trying to scramble to get out of this situation. So what this tells is, as the world is evolving more towards the software is driving many things, and as the world is trying to commonize hardware that is applicable across the world. For example, about 15 years ago, when I was working for a JV between Ashok Leyland and Continental in Chennai, we worked on a specific project. This was what is called the generic flexible instrument cluster. I'm talking about 2009 timeframe, almost like 16-17 years ago. Okay, this instrument cluster was visualized by Continental, the Germans, to work across different areas, whether it is a military vehicle, whether it is a snowplow vehicle, whether it is a tractor, or whether it is a road sweeping machine. They said this instrument cluster will remain the same. The exact hardware, it will be produced in specific plants across the world in Continental, whereas it's the software, the application, the country, etc. that will change. So this was like 17 years ago. Now you look at any smartphone, let's say Samsung, or let's say any Chinese smartphone that's manufactured in China or Thailand or India or anywhere else, you notice that the hardware is the same. It is the software that is changing, whether it is a wallpaper, whether it is a language, whether it is features, whether it is apps. So at the end of the day, the hardware is literally common, and it's even in the FMCG industry, it is more of a white goods, and it is the software that drives the features, the differentiation, personalization, etc. So software-defined vehicles are essentially emerging towards that, number one. Number two, you have been observing that over the last 10-20 years, with the emergence of electric vehicles, the technology has shifted from traditional OEM, Tier 1, Tier 2 suppliers, etc., towards what is called technology companies. In fact, you can just Google, today the technology companies from our neighboring country dominate, and they give a run for the money for the Westerners. For example, XPeng or BYD or NIO, any of these companies, they give a run for the money to Tesla, Volkswagen, BMW, etc. And in fact, recently XPeng has gotten certification to launch what is called a flying car, the first one in the world. And in fact, EHang, they are trying to come out with commercial operations of eVTOL aircraft. Okay, so it is not the traditional OEMs, the Tier 1 suppliers, etc., that have been doing this. It has been evolving more towards the technology. Okay, and there is a need for that. It is, this is the outline. The need is, when you look at the vehicle sales that have been happening over the last 6-7 years, for example, 2019 to 2025, you notice that the vehicle sales revenue are increasing. And the green numbers that you see, It's essentially the software sales revenue from the vehicle sales revenue. It was less than 5% about 6-7 years ago. Now it has grown up to almost like 15%, and it's actually increasing. And this has been pioneered by Tesla. What Tesla has done is essentially they have introduced what is called the feature on demand, something very similar to your Amazon Prime or Netflix or whatever, where you will subscribe to a specific package. There is a one-time charge for pre-installation, and then there could be a subscription service, like say $100 per month, a specific feature, let's say real-time traffic update or semi-autonomous features or autopilot or smart parking, etc. Okay, so all those things you can subscribe for them, and then you can, if you are not interested, for example, you can pay month by month, you can pay by quarter, or you can pay yearly, etc. And then you can unsubscribe if you are not interested. So Tesla has come out with this model, so other guys have started following it. Now there are specific advantages and also not disadvantages. The advantages are, you don't necessarily have to bring a vehicle to the garage, or you don't necessarily have to bring a vehicle to your factory place, etc. Okay. So essentially this brings what is called the over-the-air upgrades, where you can charge the upgrade every single time a customer subscribes or unsubscribes. Okay, that's number one. Number two, you can do what is called the Internet of Vehicle Services. Means these days the vehicles are connected, because pretty much every vehicle has a GPS, every vehicle has a USB, etc. So you are able to connect the vehicles into what is called previously it used to be IoT, then IoT became IIoT, Industrial Internet of Things. Then it evolved into what is called IoE, Internet of Everything. Then again the subset came what is called the IoV. So this is where the world is moving towards. And what Tesla has done is they have pioneered this business model where the software will bring you revenue even after the vehicle sale is done. Okay, so this is something new, and everybody is jumping onto this bandwagon. The second thing is, what Tesla has done is they have tried to do backward integration. You may be aware that they have been heavily dependent on Panasonic batteries when they wanted to do specific battery design changes, etc. So Panasonic was kind of reluctant and they were not ready to invest, etc. So Tesla went ahead and they developed their own battery, their own, for example, cell level chemistry changes, design changes, etc. And then they kind of did a backward integration, and they also did what is called extensive manufacturing setup. Means they deliberately invested in what is called a large stamping plant, where you can stamp a much bigger part, the entire door panel, etc. In single shot using what is called megaton presses. Okay, so Tesla has started investing in those things so that they can build scale. This is exactly where the other guys kind of lost the game, whether it is Chinese EV OEMs who wanted to challenge Tesla in California, or other companies, let's say like Lucid or Neo or any of these guys. Some of these players, they came close, but they could not exactly scale up. So what Elon Musk understood was software is going to be a rider, number one. Number two, he has to scale up and beat the other guys, with respect to competition. Number three, he has to bring down the prices. Number four, he has to make sure that he is not held ransom by any supplier, whether it is a battery or a motor or a chip or a cloud or anybody. So essentially the industry is moving towards what is called agnostic. Okay, so as I said at the beginning of this lecture, today you have weaponizing of tariffs, weaponizing of materials, weaponizing of different things. So fortunately or unfortunately, Elon Musk realized this a few years ago, and then he started moving towards agnostic. Means he wants to design his vehicle so that it is agnostic, whether it is an ARM chip or an AMD chip or Intel chip or NVIDIA chip, etc. He should not be held ransom, number one. Number two, if there is a specific battery supplier or a motor supplier, etc., he should not be held ransom. So he has been moving towards that, and that is where the innovation has been happening in this field. Okay. So what you see here is essentially how is this SDV market evolving? The SDV market, you may say, okay, that is innovation, etc., but why should anybody jump on this? People are jumping onto this for multiple reasons. Number one, because the Tesla has a lion's share compared to other players, and they are able to leverage with respect to cost, with respect to marketing, whatever. The other guys have been struggling to beat Tesla in their own game. That's number one. Number two, What they want to do is they want to, I don't know if you're aware, about 6-7 years ago, Tesla even got into insurance business because the regular insurance companies, they refused to work with Tesla and offer insurance to the vehicle. So Tesla started their own insurance, and in fact, it deliberately underquoted the established players by say 2%, 5%, whatever, so that he could corner the entire market. And he has done that. Why? Because he said, look, if I am selling a technologically advanced car, why should a customer pay premium on the insurance, because he is already paying for premium on the vehicle. The vehicle is supposed to be advanced technology. So why would he again pay premium on the insurance? But unfortunately, the insurance guys were not ready to buy that argument. They said, look, we don't know what this technology does. If a car gets into a crash or if the battery has to be replaced, etc., we honestly do not know how to build a insurance model to model this kind of technology. For example, the insurance guys are very good at doing what is called the user-based insurance, or let's say vehicle-based insurance, etc. For example, if you are an aggressive driver, if you are a normal driver, or if you drive, let us say, 1,000 miles vis-a-vis 100 miles, they will say, okay, take 1,000 miles means your insurance is high, 100 miles is insurance low, etc. But how do you put a number to a technology? So this is where Tesla has pioneered with respect to insurance also. So what they have done is they have looked at technology, they have looked at manufacturing, they have looked at OTA, means over-the-air software updates, they have looked at the insurance also. And they are doing what is called the key cyber security also, means you are aware, today India is significantly experiencing cyber crimes. You are very much aware. And unfortunately, today, the biggest market in the world is cyber security market, in the sense cyber crime market. It has overtaken petroleum, it has overtaken, let's say sports or any other industry, or real estate or any other industry. Today, unfortunately, cyber crime is the biggest industry in the world. And JLR, about a month ago, their entire plant got shut down for almost like 3 weeks because of cyber attacks. You're aware of that. So the industry is evolving towards what is called the zero trust architectures. Whether it is a banking, whether it is automotive, whether it is healthcare, they do not want to trust anything and anybody. If you are there, you must prove your credentials to get access, period. You could be a chacha, nani, it doesn't matter. At the end of the day, it is called zero trust. Nobody trusts you and you don't trust anybody. Okay. The second thing is something very similar to what our Indian government has done with respect to digital public infrastructure, for example, Aadhaar, etc. In fact, these days, the only thing they could hack into Aadhaar was entering wrong biometrics or deliberately putting wrong address, etc. But touch wood, nobody could crack the database of Aadhaar till now with respect to fingerprinting, with respect to biometrics, etc. So something very similar, what the industry wants to do is they want to ensure that they want to have a bulletproof security so that nobody could hack. That's the second thing. The third thing is data privacy is a big deal. You are very much aware. Because whenever there is a hack and whenever there is a ransom, etc., literally the passwords are up for sale, the user credentials are up for sale, etc. So if, let us say, there are 2 million or 10 million vehicles out there, how do you make sure that you look at the data privacy of the users? So there is a specific learning called federated artificial intelligence based machine learning algorithm that you can use for ensuring in-vehicle privacy. At the same time, you can do what is called edge computing in the vehicle, and you can also communicate with cloud for real-time updates, etc. So that is also being done. So this is where what you see as a picture, for example, the legacy architecture evolving towards zonal architecture with V2X, as you are aware. So what you see here is essentially the industry is evolving from let's say 100, 120 ECUs towards the different zones. As I explained in the previous slide, there could be a left front zone, right back zone, etc. So these guys are literally working independent of each other. So they are not exactly handicapped by any other challenges that may not impact them directly. Now, because of the geopolitics, what is happening today in the automotive world is, if you look at Valeo, if you look at Bosch, if you look at Volkswagen, if you look at any of these guys, today they have consciously developing software stack that is China oriented, that is rest of the world oriented. Because Chinese guys, they know that they will literally squeeze your under parts and make sure that you will pay, or they will use that as a weapon against you. So the OEMs and the suppliers are literally developing stack where it is Chinese dedicated, and it is also the rest of the world. Means, for example, the Chinese guys, they may say, look, you guys may have a Google, you guys may have a NVIDIA chip. They say, I don't give a damn. I'm using my own version of Google, my own version of NVIDIA chip. So if you have to work with me, you have to work with what I have. So these guys are forced to do business in China using a China-specific stack and also the rest of the world specific stack. So that is another geopolitics implication of this particular development. Okay. So as I said, the architecture, the hardware and the software, etc. are evolving. Now, as I said, in this picture, what you see is, let us say previously, the cockpit could be using, let us say, Linux operating system. The ADAS may be using, let's say, QNX operating system from BlackBerry. Whereas, let's say, the motor control unit or a master control unit may be using what is called an AutoSAR, that is open source. Okay. So, if you have to make specific changes and make these guys communicate with each other, it used to be a humongous task. Now, what the industry is doing is, they are leaving it as is, but they are working on what is called an adaptation layer. Then they will say, hey boss, Linux tum kuch bhi kar le, I don't care. QNX boss, you do whatever you want. As long as I build an application layer, as long as I'm able to communicate with you, I'm okay with that. And they are trying to build what is called the common driver. Let us say you have a printer, HP printer or a Brother printer or a Casio printer or whatever. Let's say you have a HP laptop or a Lenovo laptop, okay? You cannot force Lenovo to only use Lenovo printer. Na? There is what is called a printer driver. So any laptop should be able to work with any printer as long as the driver is available. Something very similar. As long as the common middleware, etc. is available and the drivers are available, you should be able to build what is called a printer driver kind of a thing, interface layer, and the interface layer should be able to do. So essentially what this does is, as I told you, these will help you with the rest of the world stack separately, Chinese stack separately. If, for example, this chip changes in China vis-a-vis Germany, they say, okay, all I have to do is, change this layer. I don't have to change the rest of the things. I don't have to touch anything else. So that is the advantage. Okay. As I said, it is evolving towards what's called the software oriented. Means if you want to make a simple change in, let us say, in-vehicle infotainment system, you don't necessarily have to worry about brakes. You don't have to necessarily worry about HVAC or anything else, because you are trying to work in a zone. You are trying to work in a specific feature, specific layer, and you are not exactly worried about other development. So it is evolving towards, as I said, a layer by layer architecture. So in TCS, what we're trying to do is, you can be probably working on 100 different topics, but what we're trying to do is, we are essentially focusing on digital twin. I touched upon digital twin a while ago. Whereas if you have to build a model of the physical world, you have to build virtual model of the physical, and you should be able to play with the features, the design variables, etc. to virtualize it and then reduce the software development cycle. Means you have to turn around much faster. When you look at, for example, smartphone industry, literally every month or 2 months you have a software upgrade or a software change. How are they able to do it? Because they are able to digitalize many things, and they are able to virtualize, and they are able to do what is called the over-the-air updates. Whereas the vehicle guys, they are evolving towards that right now. And as I said, data privacy is a huge challenge, whether it is a banking, whether it is a healthcare, or whether it is an automotive. So federated learning based hyper-personalization. This personalization becomes very important, because let us say you have a bunch of Teslas running in India. Let's say even in, let's say, Maruti. Maruti may have vehicles running in Jammu Kashmir, they have vehicles running in Kanyakumari, they have vehicles running in Assam, etc. So what works in Kashmir may not work in Kanyakumari, what works in Kanyakumari may not work in Gujarat, etc. So you are giving the customer an option to hyper-personalization. Let's say you are very much worried about heating in Kashmir, whereas you are not worried about heating in Kanyakumari, because Kanyakumari never gets cold. So you have to help the customer personalize the vehicle based on the features that he or she wants. Okay, so that is where things are happening. The second thing is, let us say you are running a bunch of Ola cabs. Let's say you are running 100 cabs towards airport in, say, Bangalore or Chennai, and you are running another 100 cabs for, let's say, Amazon delivery. Okay, just for argument's sake. Your Amazon delivery, you should be able to personalize the dashboard vis-a-vis your airport pickup. The same Ola cabs for airport pickup could be personalized separately. The same Ola cabs, for example, if they are running for, say, delivery for someone else, they can personalize it. So the hardware, instrument cluster, everything will remain the same. It is the personalization of the features, the dashboard, etc. that will vary. Okay, so that's where the industry is evolving. Now, you want to make sure that you protect the data privacy. So that is where the federated learning will come to picture. I will walk you through this federated learning in the next few slides. The next thing is, as I said, the industry is evolving towards co-development. Means the OEMs and Suppliers are literally in bed with each other. So how do you build trust? You have to build trust through what is called transparency. Now, how will you get the transparency? You have to define what is called the software bill of materials. Means if you are using a specific chip, if you are using a specific stack, if you are using a specific, operating system or a cloud, so there has to be transparency. So this software bill of materials becomes very, very critical. If these guys are not open to it, then you have a challenge with respect to supply chain insights, vulnerability management, etc. Let us say there is a cyber attack. Okay. Now, you know that the cyber attack came from some app that was downloaded by an in-vehicle infotainment system. Now, as an OEM, you are liable. Means you have to protect the vehicle as from cyber attack. Now, if you have to work with, let's say, Continental or Valeo or Bosch or any of these guys who supply the in-vehicle infotainment system, then unless you have access to the software bill of materials, you don't know how to contain that attack. You don't know how to manage the vulnerability. So this becomes very critical. Okay. The third thing is automated compliance. You are very much aware. You can just Google it. For example, when you look at GM, when they wanted to do over-the-air software updates, etc., because they wanted to burn their fingers, something similar to what Tesla did, they ended up literally recalling 100,000, 200,000 vehicles because they released the software without checking all the use cases. They had a bunch of bugs, and the vehicles were literally stranded in the middle of the road, and the customers were complaining. And the worst thing was GM could not reverse the software upgrade. Means let us say from version 1 to version 2 they went. Now from version 2 is not working. Means people are complaining. They could not go back to version 1. So there was a challenge that they could not even go back. Okay, something very similar in, let's say, Windows. In Windows ensures what is called the backward compatibility. Let's say you download a specific upgrade. There is a challenge. At least you are able to go back. But unfortunately, in this case, they could not go back. So the industry is evolving towards what is called the automated compliance. Means if you have to make, as I said, zonal issues are coming in. Means some guy could be sitting in Germany, some guy could be sitting in Bangalore. These guys who are working on something, you are working on something else. But if you have to release the software in the system, it has to go through automated tools through what is called the automated compliance. Means you have to comply with specific standards, regulations, etc. Test cases, use cases, whatever, edge cases, everything. And there are a bunch of tools that will ensure that they will stop you immediately if you are not compliant. Okay. So safety, safety, safety. It is non-negotiable, it is non-compromising. So this is exactly where the industry is evolving towards. And these are the areas that I am working on. And in fact, I am working on these topics with some of the automotive customers also. And as I said, something similar to the banking and healthcare industry, automotive is also evolving towards what's called the zero trust cybersecurity. Okay. And as I said, GM experienced vehicle recalls because one of the software versions that they released, they had a challenge. So the industry is evolving towards what is called the fail operational automotive software design. Means you release the software, let's say there is a challenge. At least you should be able to bring back to some intermediate version, if not the exact version. So they are building what is called the AI agents that will at least bring you into what is called the graceful degradation. Let's say instead of going from one version to two version, you could probably be going to 1.8 version through graceful degradation. Let's say 20% doesn't work, 80% works. At least you are able to go back a little bit. So that is what is happening. As I said, because of the zonal issues, microservice isolation is happening. Means, as I said, if there is a specific chip that is being withheld by China, and there are a bunch of guys sitting in China who are doing the development for you, the other guys sitting in, let's say, France, they are not worried because they have a runtime resilience. They are doing whatever they can, independent of what is happening inside. So this isolation and runtime resilience is being done in the vehicle apps. Then next thing is, if something goes wrong, for example, let us say a battery or a motor or a powertrain or anything, if something goes wrong, the system should be able to utilize artificial intelligence and it should be able to predict the fault. Okay, not worry about after the fault, means not post-mortem, it is pre-mortem, in the sense you are able to predict it. And if you are able to close the loop by self-healing, you are able to suggest. For example, today you have Copilot, you have ChatGPT. If something goes wrong, it says, hey boss, you know what, you can go to ChatGPT and say, hey, you know what, I have XYZ financial portfolio. Now I want 20% improvement in my portfolio for the next 1 year. Please suggest me a portfolio realignment, whatever. So ChatGPT can do that for you. Copilot can do that for you. So how are they able to do it? Because they will say, hey, what is your risk factor? How much are you going to invest every month? What is your SIP? What is it that you can do? What kind of risk factor you can take and all that. Based on the inputs, it can suggest you. Something very similar here. Based on the predictive faults that a system can see, using artificial intelligence, the AI agents are able to recommend self-healing. But at the end of the day, it is the human that takes the decision. The system doesn't take the decision. At the end of the day, it is the human that takes the decision. You are very much aware about 6-8 months ago, when India was launching, ISRO was launching along with the Nisar satellite, along with NASA. It was not NASA that pulled the plug on the launch. It was ISRO that pulled the plug on the launch. You may be aware. Because they went through what is called the fault detection, and they went through what is called the closed loop healing. In the sense, they said, hey, you know what, something is going to go wrong. They said this particular sensor, the data is weird, there's something, there's an anomaly, kuch to gadbad hai. So they pulled the plug literally at the last minute. And the NASA guys were very happy, because they said, look, at least we pulled the plug on the launch, but after 2 days or 3 days, they launched again. So they could exactly pinpoint what went wrong, where it went wrong. They fixed the software, and then they again did the testing, and then they launched after about 2 days or 3 days. Okay. In fact, in one of the ISRO launches, when they pulled the plug on the launch in the last minute, they literally were ready in another 2 hours. Literally in 2 hours, they were ready, and they did the launch before the next window was closed. Okay. They literally did the launch in another 2 hours. They fixed the problem in 2 hours, and they did the launch. Okay. So that is where the industry is heading. As I said, digital twins are going to be critical. Okay, these will help you with respect to product. This will help you with respect to process. This will help you with respect to performance, and it will help you with respect to behavior and also cross domain. Means sometimes the ADAS and the autonomous vehicles, they have to work together. So you cannot have independent systems operating with each other. So you must have what is called a cross domain cyber physical system. So that is also happening. And as I said, these days, a lot of data, because you have high power computing chips available in the vehicle, you don't necessarily have to transfer the data to some central server or something. So you can do what is called the edge intelligence. How many of you read about kill switches in Yutong buses in Norway just about 3-4 days ago? One of the drivers found out by accident that Chinese guys can kill a bus in the middle of the road that is running in Norway, because it's a Yutong bus, and the data was getting actually transferred to a server, backend server in China. So they were exactly able to monitor which bus is running, where it is running, how many miles, etc. So this has been a huge challenge, even in the the cranes. In fact, there was a panic attack in US Senate and US Congress, because they realized that literally 60 to 80% of cranes that load and unload the goods in Los Angeles airport, those cranes were of Chinese origin, and these guys had sensors, IoT devices that could transfer the data to China. So if China wanted to literally screw up US economy, all they had to do was just to use a kill switch and then screw up all those cranes. Okay, so this is exactly a challenge today, where even though you are able to do edge computing, your edge devices have what is called the intelligence, and you must make sure that if you have to avoid getting ransomed, getting screwed by some your vendor, you have to make sure that all the edge computing is happening on the device, and you don't transfer the data. And even if you transfer the data, the server has to be residing locally and not in some country of origin, let's say China or somewhere else. So this is where the industry is evolving. So the future work is essentially, as I said, Internet of Vehicles are evolving. So this information is available in the open domain. You can go through it. Essentially, what you're trying to do is, if you have a bunch of vehicles running on the road, you don't necessarily have to talk to a central server somewhere. You can always have what is called a local LAN with respect to, it's called VANET, vehicle network. For a bunch of different vehicles, they could communicate to each other, etc. And if there is a, let's say, traffic jam, or if there is an accident or something like that, if there is a bad weather or something like that, these guys are able to talk to each other. They don't necessarily have to go back to the central command. That's number one. Number two, as I said, because of the data privacy, etc., you don't have to necessarily transfer all the data to the central cloud. You can only transfer the limited data, and that can be done. The next thing is, because these days lots of things are connected, and you are looking for what is called the OTA, means over the air updates, etc., you have a challenge with respect to security on the cloud. So you are trying to protect the data wherever possible, and you are only trying to share whatever data is allowed into the cloud. So this is also where the industry is evolving. For example, today you have something very similar to what is called a patient health record, history record. For example, PHR. Let's say you go to a Kaveri hospital or Kamineni hospital or Manipal hospital or somewhere. They will say, sir, have you been here before? So your history record is available in the hospital. They know, okay, TK, you came on XYZ date, you did XYZ, treatment, etc. So they have a record of what you have done, what you have gone through. So something very similar, vehicle history record. You are able to capture that, and then whether that particular vehicle is sold in Kanyakumari or Kashmir or Assam or somewhere, as long as the vehicle history record is available and as long as it's not tampered, you're able to figure out what kind of service record, what kind of upgrades, changes, etc. that the vehicle went through. So you are able to understand it. So why is this important? Because number one, it helps the security guys. You are very much aware. Even actors like Dulquer Salman or Srikanth or Srinath or whatever these Kerala guys, they have secretly and illegally imported vehicles from Bhutan through army, and they have all the high-end vehicles. And ED recently captured some of them. They confiscated some of those vehicles because somebody tampered with the vehicle history record, and also somebody made sure that they bypass the customs and blah blah blah. They have done it. So it actually ran a red flag through the security establishment because fortunately in this case it was the movie actors, and the movie actors, because they did not want to screw up their reputation, they cooperated with the security agencies, etc. But imagine somebody like this, some terrorist or somebody like this doing something like this, and then something very similar to what you saw on the terrorist plot. The 32 vehicles, 34 vehicles that were there, they were trying to detonate. If you tamper with the vehicle history record, you have no clue. The security guys have no clue. What happened to that vehicle? Where did that vehicle come from? What is the mileage? What is the engine change? They have no clue unless you have this VHR and unless it is not tampered with. So these are some of the things that are available, but they should be done through what is called the connected cloud services. Thank you so much.
Yeah, very interesting talk, Arun.
Thank you, sir.
I used to run a company which was into wiring harness.
Okay.
And it was ages ago, copper age, so to say.
Okay.
So tell me if, they used to talk about a single universal bus which will carry all the information. Let's say I want to put the light on. So I only need power to be supplied to it, and there's a switch, and the information bus, does that switch on, switch off.
Correct.
So you reduce the number of wires. You have only one wire which has all the information going.
That's called multiplexing system.
I don't even know the terminology these days. So what is it? How is the development in that area?
See, the multiplexing system works because essentially it works on what is called the CAN, LIN protocols and things like that. So in fact, we worked on the multiplexing system in JNU buses. You look at any of the buses, maybe like 5-10 years ago. For example, the Jet Airways buses or the SpiceJet buses or the Air Deccan in those days buses that will take you from the airport to the airport terminal to the actual aircraft. When you look at the Ashok Leyland buses, literally every single bus, the instrument cluster that you see below the steering wheel was designed by us. And we had what is called the multiplexing system where we got rid of kilometers and kilometers of wiring harness. We literally had 2 wires running from back of the vehicle to the front of the vehicle because it operated through what is called the CAN and LIN. So previously it used to be, as I said, there could be 100 different wires running. So the CAN came into picture. That worked very well. There is nothing wrong with it. But the challenge is, as I said, today you have tons and tons and tons of data because the number of sensors has increased, the number of ECUs has increased. So the multiplexing system, the speeds are very, very slow. So the CAN LIN speeds are very slow. So you have to go towards the next generation, what is called the vehicle level Ethernet, means where you are talking about 100 your gigabits per second, etc. 5G, 6G kind of speeds in the vehicle. Okay, and if you are, let us say, sitting in a train, let us say you are traveling from Tokyo to Yokohama or Tokyo to, let's say, Hiroshima. You're traveling in Shinkansen at say 380 kilometers per hour. Okay, if the vehicle is traveling at that speed, the data that vehicle has, the train has, the data should also be able to be transferred through local, communication through so much of speed. Otherwise, you cannot control that vehicle. You cannot, track that vehicle, etc. So you cannot say I will have a CAN LIN in my Shinkansen that is running at 380 kilometers per hour. That's not going to work. So you must have a much faster Ethernet-based communication network in the vehicle. So that is where the industry has actually started evolving. So something very similar is happening on the automotive industry also. So essentially that will reduce your wiring harness, that will increase your speed, that will give you what is called the literally real-time data analytics and predictive maintenance.
Arunji, as usual, it's a very extremely, subject of extreme importance, but it is very futuristic. See, I had some idea about this few years back. We were talking about, probably a decade back, we were talking about AutoSAR platform, where the ECUs were almost all the auto manufacturers came in a single platform. or that created some sort of stability. But now you are talking about these futuristic things. You already touched that point, whether we have to have a common base so that over which the individual companies can build up. Is there any such developments or protocols happening around? Do we have some opportunity as companies,
SDV,
as enterprises?
Yeah, in the SDV, there are a bunch of different. There is something called a SOFE, SOAFE. There is something called Eclipse Foundation, and of course WEF, World Economic Forum. So these guys are driving for a common platform. So what is the definition of common platform? That is still being evolved. So that is as we speak. Where bunch of different suppliers, as I said, the suppliers are literally in bed with OEMs. So the challenge is today. Let us say I am. Now, as NVIDIA, I have a tie-up with Volkswagen, I have a tie-up with Chinese guys, I have a tie-up with Toyota. So, as an NVIDIA, how will I, of course, it is always good for me to have a common platform because it will help me reduce my development time. But I should also make sure that I segregate. When I work with GM, when I work with Volkswagen, when I work with Tesla, when I work with Chinese guys, NVIDIA has to differentiate now. Because you have to protect your business privacy, etc. for that particular business. So how do you make sure that you attain a common platform, and how do you make sure that you also work seamlessly with another organization? So this is still being debated. So to answer your question with respect to AutoSAR essentially gave you open source where the something very similar. For example, let us say, Harish Pathak touched upon C-type. Whether you build a small charger or a big charger or a laptop or smartphone or something like that, at the end of the day they said, look, your charging port has to be in C-type. तुम laptop बनाओ या smartphone बनाओ या printer बनाओ या कुछ भी बनाओ. At the end of the day, the charging port has to be C-type. That was the standardization. Okay. So something very similar. How do you make sure that there is a standardization on the SDV? That is still being debated without compromising on individual business interests. That is still being debated.